Hi friends, let's see the continuation with the course from the previous session. We discussed about the processors and their generations and evolutions of processors. And coming to embedded domain, so you need to focus on microcontrollers basically. So most of the cases for all kinds of firmware development, you are trying to use microcontrollers. But as a beginner, how to understand a controller? So whenever you are trying to understand a controller, so from all academics, you may get the basic microcontroller names like 8051, and now you are hearing the popular microcontroller family which is Arduino. But Arduino approach is different, whereas the other microcontroller families like 8051, PIC microcontrollers, and ARM series LPC2148 and STM32, these kind of controllers programming and approach is quite different than your Arduino. So you need to focus on the microcontroller understanding. So once you are aware of how to understand a controller, it is a general process you need to apply for every microcontroller in the world. So no need of by heart the things from controllers, and my suggestion is don't by heart the controller approach. Okay, so you need to follow the block diagram of microcontroller first of all, then it clearly tells us what are the supporting features from the microcontroller. So this will change from family to family, this will change from controller to controller. So just by looking block diagram of microcontroller, you can easily understood that what are the features, means what kind of applications you can develop with this controller, you can easily understood. And what are the different memories which will support. So like what is the maximum program size I can do, or what is the maximum extension of applications. See, application is not your choice, application is always looking for some work by the customer or client. So you need to know whether this controller is possible or whether this controller is suitable for your application or not. You need to understand just by looking block diagram. You can conclude or you can know very easily. So this block diagram I just drawn for 8051. This is, I think you may get from academic also, but my suggestion is start learning microcontrollers from basic families like 8, and then you can move on to 16, and it is easy to understand 32-bit controllers. So don't start high-end microcontrollers like 32-bit directly, so which is not advisable to understand whatever your academics which is not completely close to your 32-bit families. So you need to understand a few words like memories and types and IO ports. What are these? So what way you can use all this? And from 8051 microcontroller block diagram, I want to clear you what is the importance of each block. And always microcontroller is designed for only applications. Okay, so not for just this microcontroller is good, that microcontroller is good, not way. Okay, every microcontroller having its own limitations and its own features. See, you cannot do video call from basic mobile phone, because that basic mobile phone having a basic device, so which has low-end microcontrollers or very beginning microcontrollers they used for these mobile phones. But now you are updated to many features because internally the programmable device which is changing from application to application. Okay, so let's see this basic microcontroller block diagram and their features and what is the importance of each block. You will see one by one. And the first block for every microcontroller has its own CPU, which CPU full form is very clear: Central Processing Unit. So this central processing unit, like you can easily say that this is one of the processor for your microcontroller. See, every controller is integrated with processor compulsory as a CPU, and CPU have three important characteristics. The first and major important thing about processor is bit capacity. So every processor has its own bit capacity, which means how many binary inputs it can process at a time. So that will be the main motto of understanding this bit capacity. So As you know that every programmable device accepts inputs in the form of binary, which is zeros and ones. So that is the only reason you need to understand the importance of bit capacity, and based on the processor what they use it to design this whole controller, that will decide the controller bit capacity also. Okay, and the second point from CPU, you need to know architecture. Every processor has its own architecture. So this architecture, which is every processor has its own architecture in the form of buses. Okay, so see the processor which is connected with all these individual blocks with the help of standard buses, and these two buses names are address bus and data bus. So your processor is connected with these two different buses, address bus and data bus. And most of the cases, simply on books you may find architecture is Harvard architecture or Van Neumann architecture. What it means, what is meant by, and what the activity of this address bus and data bus from the processor or CPU. So basically your address means, technically this address is defined as name of the block or cell. Suppose you are dealing with some memory, and memory is which is divided into some cells, and each cell has its own name. So if you are trying to save some information in the memory, you need to use its memory cell name particularly, or you are trying to deal with IO port. Every IO port also has its own name. So name technically defined as address. So when someone is addressing you means, so they are trying to call, so they are trying to use that resource. Okay, the same way every peripheral which is connected with this CPU with the help of address bus, and address bus work is very clear here. The address bus which is helping us to access the block with the name. Okay, and address bus is always unidirectional. Your CPU only has the right to access any peripheral here. So no peripheral has right to access CPU. Okay, so only CPU, whenever CPU is called so and so address, that particular peripheral will respond. Okay, so to carry that address you need this address bus. And what is meant by data bus? So data means the information or value in that cell or value in that memory location. Okay, so value or information or content, this is technically named as data. Okay, so this is very clear. The information present in the cell is data and information name is address. And based on these two buses, your CPUs are having two architectures mostly, either Harvard or Van Neumann. What is meant by Harvard or what is meant by Van Neumann? Most of the cases, if these two buses sizes, so even buses are also measured with the size bit, which is 16-bit address bus, 8-bit data bus, or 20-bit address bus, 16-bit data bus. If these two buses sizes are different for any processor, so if buses sizes are different, that architecture is Harvard architecture. And any CPU will maintain the same size of address bus and same size of data bus. This is Van Neumann architecture. In CPU, the buses sizes are different. This is Harvard architecture, and buses sizes are same. That is Van Neumann architecture. And most of the cases, and other difference with architecture is, if the processor follows Harvard architecture, you will have separate data memory, separate program memory for controllers. And if you have Van Neumann architecture, you may find same memory for program, so, and same memory for data. So the same section of block which is divided into two parts, program memory and data memory. So this kind of architecture, this is Van Neumann. And in the case of Harvard, so CPU has separate data memory and separate section of program memory. So this will come under Harvard. So these are the two differences you need to understood from Harvard and Van Neumann. So in the case of Harvard architecture, so these buses sizes are different, address bus size is different, data bus size is different, and in the case of Van Neumann architecture, address bus size and data bus sizes are same. And again, the knowing of address bus sizes, for example, so you have 16-bit address bus for any processor. So what you need to understand, this will decide the memory capacity also. So the processor can access maximum 2 power 16 memory locations, which means 65,536. And if you convert into kilobytes, this simply you need to divide this thing with 1024 because 1K means 1024. So you will get 64K. So this is the importance of knowing buses sizes and buses differences. Okay. So once you have 16-bit address bus, you can access maximum memory 64K. You cannot connect whatever the amount of memory you required for your application, you cannot do with the devices. So again, memory also has its own limitation, and that limitation will be decided by program address bus and data bus sizes. And what data bus size decides? Again, the data bus size decides the maximum value. Suppose the controller have 8-bit data bus, and this 8-bit data bus which will decide the maximum value 256, the amount of value how much I can keep in one location, so which is 0 to 255 only. Suppose your input is 1000, so you need to use 2 memory locations to save your input 1000. If the value is less than 255, the device will utilize only 1 memory location. If your input is more than 255, you need to use 2 memory cells. So suppose the data bus size is also 16-bit, so you can access the value from 0 to 65,535, which means up to 65,535 the device will use only one single memory location. That is the difference. So these two buses are very important for any device and sizes, and based on sizes you can decide the number of locations, and in one location what is the maximum value you are storing. That is the major important information behind this architecture. So every processor has its own architecture, and based on architecture you can decide all these points. And the third one is registers, and every processor will support some list of registers. Like I think if you study that 8085 microprocessor, which have A register, B register, C register, D register, and in the case of 8086 processor you may have AH, AL, BH, BL, which means higher byte, lower byte, all this. And coming to any microcontroller, so again you have inbuilt processor, and this processor having some amount of registers, so like A, B and R0, R1. Coming to 8051, you have register names like A, B, R0, R1 like this. But if you go to 32-bit level devices, so I think you may not find this register concept, so this will turn into cache memory. Okay, so cache memory again, which is for temporary storage. So even for registers are also used for temporary storage from any microcontroller. So this is the information behind this CPU, and this CPU means processor indirectly. Every microcontroller, even your LPC2148 or STM32 microcontrollers also designed with ARM processor, like ARM7, ARM9, ARM11. So every microcontroller, but LPC2148 is the controller from Philips, but they are using ARM as a processor. And even STM32 is a microcontroller from ST Microelectronics, but they used Cortex-M processor as a CPU. See, without processor there is no controller in the market. So this you need to conclude. And from processor you have to know all this information, like how many bits it can handle, and what is the architecture, and how many registers. So this information you need to know about any individual processor. So this is the only learning process. If you are working with 8051, you have to know this information compulsory. Even you are working with STM32, you need to know this information compulsory. So that is the only reason. So don't by heart the things, you need to know the points what you need to know from the processor. So these are only headings I am saying. So you need to go more in depth about this information, like what are the buses and what are their sizes, and based on sizes what is your memory calculation. All this you need to understood from the CPU. So this is very clear about one first important block from the microcontroller. And moving on to the next block, which is RAM. RAM stands for random access memory. So this random access memory, again, which is helping us to store the data temporarily. Already you have a temporary storage unit which is registers, but again, what is the importance of RAM? So RAM is also used for temporary storage. Then the difference between register and RAM, again, so I already said that registers are used for temporary storage and RAM memory is also used for temporary storage. But coming to the difference between RAM and register, even if you are using registers in programs, indirectly every register will use RAM memory location, which means all registers are the dummy names of memory locations. So mostly for all simple operations like 2 numbers addition or 2 numbers multiplication, you simply moving one value into first register A and second value into B register and using instruction add A comma B. So this is very easy for the beginner to do all arithmetic and logical operations. But whenever you are trying to attempt for applications, so application means you have a huge input data. I have random data like more than 100 inputs, 150 inputs or 1000 inputs, depends on application. So whenever you are working with applications, your registers are not sufficient to store your input numbers. So you need to deal with memory compulsory. Okay, even though you are using register in program, indirectly it will use memory location only. But which memory it is using? RAM. RAM is always helping us for temporary storage. And this memory, which is called as data memory in microcontrollers. So any data you are trying to use, you are trying to save in microcontrollers, it uses only RAM. So again, RAM have one more thing. Whenever you switch off your microcontroller, it will lose the complete data. Okay, so that is the only reason which is called as temporary storage. Like this is used for only processing the entire code or processing your applications while running the CPU. Okay, and your RAM, which will change from controller to controller, but as in basic microcontrollers you may find in bytes. But moving on to 32-bit category controllers, like you may get KBs and MBs and GBs. Okay, so once the device is supporting more RAM, your operations will be quick. So that is the only reason in our regular products, in our daily regular products like laptops and mobile phones, whenever you are trying to buy, you will check the memory size, how much of RAM. Okay, so that is also play the major role while running your programs. Okay, but in basic microcontrollers, the amount of RAM is in bytes. But moving on to next generation devices, so which is keep on making the size more, which is turns to KBs, MBs and GBs. Okay, so but this is for only temporary storage. Finally, that is the data memory for microcontroller. And the ROM stands for read only memory. So this memory, which is used for permanent storage. So whenever you are trying to save any information permanently, you need to use this section of block, which is ROM. So this ROM, which is used for applications to store the code or to store the program. So this memory is called as code memory or program memory in microcontrollers. Okay, so even you turn on your laptop, so which runs with operating system support, and operating system which is saved in a local disk, which is hard disk. So and whenever you turn on, the processor will fetch all the operating system instructions and it will execute. But if you erase the operating system every time, if you turn off your laptop, you need to load operating system whenever you are trying to turn on your laptop. So that is very great difficulty for us. So that you are using one permanent storage, which is ROM, and you are saving our operating system. Okay, so whenever you turn on your device, it will fetch again your operating system instructions and it will execute. So that every time you need to save your application code in a permanent storage type, which is ROM. So this is again, so this is for kilobytes in basic microcontrollers, but once you move on to next generation controllers, which is again moved to MBs and GBs. So now the advanced controllers which have GB support of ROM memory, so that you are aware you can run even operating system. Why it is not possible to run operating system in low end microcontrollers? Because operating system minimum file size is in MBs or GBs, but basic microcontroller supports KBs of ROM memory. So that is the only reason in 8-bit microcontrollers you are not running operating system, you are simply writing one embedded C program and creating hex file and you are loading into microcontrollers. But you are moving to 32-bit like STM32 or Raspberry Pi boards, you are running with the help of operating system. So because the amount of memory they will support in GBs. So once the device is supporting GB amount of memories, you can load RTOS or regular operating system into the devices. Okay, but finally your ROM memory is helping us for permanent storage. And the next section is IO ports. The name itself, IO ports, input output ports. So any peripheral you are trying to connect with controller. Okay, so from any microcontroller, IO ports are dedicated for connecting sensors, connecting displays. Any peripheral you are trying to connect with microcontroller, you need to depend on this IO port. Okay, so like every system is designed with a combination of inputs and outputs, right? So like sensors, keypads, keyboards, displays, motors, loads, whatever you are trying to connect with microcontroller, you need to choose this feature from microcontroller IO ports. And this IO ports quantity is also changing from controller to controller. So like in basic microcontrollers, you may have only 10 IOs, 14 IOs, 25 IOs, 32 IOs. But once you move into again advanced families, there is a huge support of IO lines, 64 IOs, 100 IOs. Okay, so depends on application, they may choose different controllers. Okay, but any microcontroller which will come up with standard few number of IOs or more number of IOs. But IO ports purpose is also very clear. Use it for connecting peripherals like sensors, displays. Okay, and timers and counters. This block, this is for delay generations. Most of the cases, every application needs some delay operations whenever you are handling like motors, displays. Okay, so because your external devices are not quick as your microcontrollers, they may execute your instructions with microseconds and nanoseconds fast, but external peripherals are not responding that much quick. So you need to provide some delays between logics. Okay, if you are keeping high logic, then you need to apply delay and then logic low. Okay, if you make it logic high and logic 0 in the next line of code, your external peripheral is not going to respond with that much quick time delay. Okay, so that if you are looking for accurate time delays, you can choose the block or you can use the feature from microcontroller timers. Any microcontroller which will give some amount of timers, maybe 1 timer, 2 timers, 3 timers, 4 timers. So that depends on the controller family. So whether you are dealing with PIC family or ARM family or LPC family or STM, but every microcontroller come up with some standard timers. Again, timers are also measured with bit capacity, 16-bit timer, 8-bit timer, 32-bit timer. So we will see more in depth while doing applications with the microcontroller. And counters, again counters is also used for external object counting applications, like you have any bottle counting product or any seed industry, you are trying to count bottles, you are trying to count packets, you are trying to count any object, so you need to choose this counters block from the microcontroller. Okay, so then interrupt, basically the standard meaning of interrupt is very clear. Interrupt means disturbance, but how can you say that interrupt is a feature of microcontroller? So our main motto is trying to do applications with microcontrollers to replace human being, right? So whenever you're trying to write a certain amount of application, so if you write the application code or application program, which means do my work like this, your microcontroller is continuously executing this amount of block or code block. So once your microcontroller started execution, so which will come up from top to bottom or bottom to top, that depends on execution process of family or controller, but most of the cases your execution process from top to bottom. Okay, so like if you have multiple conditions in the program, like I'll say the difference between polling and interrupt. Okay, so if you are trying to write 4 conditions in a program, the first condition, which is checking, if it is not true, then compilation move on to second condition. If it is not true, then your compilation move to third condition. So this is the execution or sequence execution of your device. Okay, but whenever the first condition is true, in the same time I am giving third condition input also from outside. So what is the reaction of your controller? Your controller will never take care of the third condition, even though it is a true, your system is not responding for your input. But so that is an important task for me, that is an important case in the case of my application. Okay, but it is not possible to assign priority if condition in programming. Okay, so you don't have priority for third condition, you cannot set priority for fourth condition like this, but always compiler will do from bottom to top or top to bottom. Okay, so it never take care of the middle condition priority or third condition is priority or fourth condition is priority. So how to overcome these kind of situations? So you can use this interrupts. So interrupt is designed for if you have any high priority task from the application, you can stop that current running process and you can divert it for ISR execution. So ISR, the name itself, interrupt service routine. So this interrupt service routine, which is implemented because whatever the running program, you need to stop or you need to break it and come for ISR execution and finish this high priority task and go back to main program as usual, where you stopped, and go back there and run your main application. Like the simple you can find out from ATM machine. So once you are not swiping your card, your ATM machine keep on showing advertisements. So but once you swipe the card, it immediately stops that showing advertisements and come to transaction, because for ATM machine transaction is an important task. So after finishing your transaction, then again it will go as usual for showing your ads or showing your whatever it is doing previously, then it will go for it. So this kind of activities you can do with only interrupts. Okay, without interrupts you cannot set any high priority task from the application. Okay, so these interrupts which is supported for all microcontrollers, but in basic microcontrollers you have limited number of interrupts, like 3 interrupts, 5 interrupts, 6 interrupts. But if you moving to 32-bit generation controllers, so your number of interrupts are high, maybe 10 interrupts, 30 interrupts. So you have more flexibility with interrupts, you can do more priority tasks in your application. So these interrupts which are very important for pharma and medical products. So these interrupts which are highly used for such kind of application, but in regular applications you can do with your regular IO port programming or in regular process. Then the last block from microcontroller, which is serial port. So serial port, already I have IO ports to deal with the external peripherals, but again you have serial port with microcontrollers. The serial port which is dedicatedly used for modules, like who have protocol support. So whereas IO ports are used to connect external peripherals directly without taking any without knowing any rules and regulations, but whenever you are dealing with serial port, you should learn compulsory about the concept protocol. So without knowing protocol, it is not possible to use serial port. So protocol, simple definition is set of rules and regulations. So without following rules and regulations, your device is not giving data or taking data. So again, microcontrollers have different number of protocol support, but whereas in basic microcontrollers you may find only one protocol, which is UART. But moving on to next microcontrollers like STM32 or Raspberry Pi, you may get support of LAN, USB, CAN, SPI, I2C or USB. So these are the huge. If the controller is supporting more number of protocols, I can communicate with more devices at a time. Like how your laptop is able to connect Ethernet directly, USB directly, or HDMI directly, Wi-Fi directly, Bluetooth, like all this you have some wired protocols or wireless protocols. So this is the importance of supporting on-chip protocols from the microcontrollers. But in basic 8-bit controllers you have only one protocol support, which is UART, which is keep on moving or keep on enhancing the number of protocols for new generation controllers like STM32 or LPC2148. They have huge number of protocol support, at least 4 to 5 protocols. Okay, so this is the importance of each block from microcontroller. Every block has its own importance. Again, CPU is a major important block from microcontroller. This is used for complete processing and fetching instructions from the memory and taking data from IO port and doing certain operation and again push back to IO port output. So this is the entire complete controlling under CPU, and memories are dedicatedly used for storaging purpose. One memory for temporary and one memory for permanent, and IO ports for connecting peripherals, and timers, counters used for delay generations as per requirement, and interrupts for high priority task, anything you have from your application, and serial port used for communicating with external modules. And in the next session you will see each block quantity and their usage. Thanks for watching.